Hi everyone, today I'm going to talk to you about the Singleton design pattern. The Singleton design pattern is an object-oriented design pattern that restricts the instantiation of a class to a single instance. So basically what that means is if you have a class, you can only create one object, and if you try to create any further objects, it's just going to return that initially created object back to you. So there's only ever going to be a single instance of the class. You can use this in some places where you might want to sort of control access to things just through a central place, and like maybe you want some sort of cache and you want it to be a singleton. So that might be a use case for when you might use a singleton design pattern. They're pretty easy to implement if you're not looking for thread safety, and I'm going to provide you a very simple example of what you can do to implement a singleton in your code. I won't be showing you a thread safe version. If you want to dive a bit deeper, you can find some things online. Now that we know what a singleton is, let's go ahead and dive into an example of how to create one. So what I'm going to do is I'm just adding a class that will serve as my singleton. I'm just going to give it the name singleton so it's quite clear. I'm going to have all this code available on GitHub, but it's going to be alongside some other design pattern code. So it's useful to sort of name these quite clearly as to what they're representing. You make the class sealed so that it can't be extended and inherited from, and that would effectively mean that you weren't able to control just being a single instance, because something could inherit from and you could create multiple instances of that. I've also made the constructor private. I'm just showing you here that if I try to call my constructor directly, it won't let me, and that's because my constructor is private, and so it can only be called from within inside this class. So you can see that's giving me the error that the constructor is private. There's no constructor available for me to call. So if I go back to this class, you're going to need to call the constructor from inside the class, and you're going to want to have a static field that represents the instance of the singleton, so that if that instance is null, you're going to want to go ahead and instantiate the singleton, and if it has a value, you'll just return that singleton. And because you're inside the class, you can call you can actually go ahead and call the constructor. I'm creating a property as well that I can use and check my backing field, which is the underscore instance field. And I'm just going to create a getter. I don't want to create a setter because I don't want people to be able to create or set instances here. So first off, I check if the instance is null, and if it is, then I'm just going to construct a new instance using my constructor. And once that's done, whether it's null or not, it will return the instance. So at this point, the instance will have a value. I want to remind you that this isn't thread safe. If you want further options for making it thread safe, I'll link some in the description below. So now I can go ahead and access my instance of a singleton by using that singleton.instance property that I've defined. And it's going to return back the one instance of my singleton. And there'll never be more than one instance because I'm controlling access to it by making the class sealed and the constructor private. So now I'm just going to show you that if I were to have multiple references to the singleton, it's still going to access that same instance. So what I'm doing is I'm creating some class fields. So I've got the counter, and I've got my function, and I'll be able to call that on my instance of the singleton. So I want to be able to increment the counter, and I also just want to be able to output the value of the counter. Like I said, you're probably more likely to use this for something like caching, but for the purposes of an example, this is a very simple way to demonstrate it. So if I call increment counter, it'll increment the counter. If I call log counter, it'll just console log what the counter value is. So I've got my singleton and I'm going to increment the counter. I might do that a couple of times so that at this stage the counter should have a value of 2, and I might then go ahead and get a new instance of my singleton, but it is actually going to be the same instance because it is a singleton and I can only create one instance of the singleton. So there you go, I've got my singleton 2, and if I call log counter on that, it should log 2 because it's actually the same instance as my singleton. So what I'm expecting here is, I'm going to log my singleton as well just to show you that they're both going to get the same value. So it should increment the counter twice, so to 2, then log 2 out twice to console, then it's going to increment the counter to 3, and then it's going to log the counter, which should be 3. And even if I call the initial my singleton object, it should log 3 because they are the same instance. So you can see no matter what I do, no matter which instance I use or which variable I use, it's always going to output the same value because it's using the same instance, and so they're accessing the same fields and they're able to control access to the same values, and you've not got multiple values going on there. So I hope you've enjoyed this tutorial today, and if you have, please like and subscribe for more content.